Hello guys, in today's class we shall discuss the effects of faults. This is nothing but the aftermath of faults. Means due to the fault what all things have changed in the system you're going to see. So we know that due to heavy short circuit current it causes damage to the equipments. So due to this what happens, there results overheating as well as high mechanical forces will set up in the devices. This is the one of the effects. Second one is they may also cause fire hazards as well as they may spread to the other part of the system. The system may be healthy, okay, so we need to isolate it as soon as possible, otherwise healthy parts of the system will also get affected. Third one is reduction in system voltage. So due to the fault there may reduce the system voltage of the healthy feeders. So resultant what happens, there is a resultant loss in the industrial loads. We need to shut down the loads because due to the faults. So fourth one, due to the fault, so there creates unbalance of supply voltages as well as current, thus by heating the synchronizing machine or synchronous machine, your alternators will get heat up due to the setup of harmonics in system. So due to this what happens, the heating may increase or eventually your system may fail or your alternator may fail. Next one is loss in system stability. So system stability is that where your voltage, current as well as frequency, everything is having a desired parameter or have a constant parameter. Okay, any voltage is constant, current may vary depending upon the load and all. But due to this what happens, there may get loss in the synchronism. So synchronism, your generator may come out of the synchronism if the stability gets loose, or sometimes even complete shutdown may occur. So complete blackout may occur if the system gets destabilized. Next one is the last ultimate is what? Interruption of the supply to the consumers. So consumers may fail, may arise. So there is a interruption of supply. So due to the interruption of supply, what happens? There may result a loss of revenue, okay, to the generating stations or the power supplier. Okay, any power supply company may face this thing, that is loss of revenue as power supply gets interrupted. So that's why there is a interruption of supply, there may be resulting in what? Loss of revenue. Okay, so that is why we need to use high grade, high speed as well as reliable protective devices so as to stop all this, the aftermath of faults. That is, effect of faults can be reduced by using such good quality equipments. So as to what? I can't say that 100% of faults can be reduced, means some extent of faults can be reduced so that consumer can enjoy the uninterrupted power supply. Okay. So next topic is fault statistics. Here we know that our transmission lines are even more than 100 kilometers in length and they are continuously exposed to the atmospheric condition. It may be wind, it may be rain, it may be sunlight, anything. Okay. So what happens? There is a chance of fault occurring due to the storms or falling of any heavy object on the transmission lines on your anything. Okay, so in that case what happens, here some statistics the power system engineers have made, and as per them, so total number of faults as well as elements. So elements include overhead lines, underground cables, transformers, generators, switch gears as well as current transformers, voltage transformers, relays and other controlling equipments. These are some of the elements present in the power system which you all know, and out of which you can see that major, that is percentage of faults has occurred on the overhead lines. It accounts 50% of total faults. See overhead lines contribute more faults, that is 50% of the total faults. I can see underground faults is less, that is 9%, and transformers 10%, generator 7%, switchgear 12, as well as switchgear includes your all CTs, VTs, relays, and control equipment contributes 12%. So the concentration of the designing the system fault free should be more made on overhead lines because it contributes 50% of the total faults. So while planning and designing, we need to take more care on this overhead lines, so that total percent of faults can be reduced, okay, when compared to the others. Again, here we have a second table where you can see that frequency of occurrence of different faults on overhead lines. See, I already told you that faults are classified as well as in terms of shunt faults as well as series faults. Shunt faults, we have both symmetrical faults as well as unsymmetrical faults, and series faults are nothing but what? Open conductor faults. And here you can see that out of your series as well as shunt faults are more here, and that too they are unsymmetrical here. Okay, you can see line to ground fault is there, line to line fault is there, and LLG fault is there, as well as three phase fault is there. So out of all these faults, you can see line to ground fault occurrence is around 85% of the total faults. So LG fault is more, it is occurring more, and also it occurs, I told you, at the junction ends as well as due to the insulation failure. So what happens there? Line to ground fault occur more in nature. Okay, and you can see LL fault is less, 8%, as well as double LG fault is 5%, whereas three phase fault is 2%. So again, power system engineers have to concentrate on this particular fault so as to make the system free from, can say, less vulnerable to the line to ground fault. That is, you can 85% fault. So that's why the reason we need to concentrate more here. So such system we have to design. That is, power system engineers should design. Okay. And now coming to the zones of protection. Now let us see what exactly the zones of protection mean. A power system is divided into number of zones for protection. So protective zone covers one or two elements of power system. Okay, we know that elements include here CTs, VTs, transducers, relays, circuit breakers, maybe your generator, it may be a transformer, it can be any element. So protective zone covers one or the two elements of power system. Okay, so depending upon the need as well as the operation, so whole power system is divided into number of zones, and each zone has CTs, VTs, or it may be transformers, or it may be generators. That will be clear by looking at the coming diagram. Okay, so entire power system is covered under one or the other protective zone. It is not like transformer is left out of the protective zone or generator is left out of the protective zone. It is not like that. Each and every element fall under in one or other protective zone. And third point, that is, adjacent protective zones must overlap each other. Adjacent protective zone must overlap each other. Let us see what exactly that mean. Okay. Next, fault occurring in fault zone may trigger more circuit breakers than required. So low extent of overlap reduces too many circuit breakers tripping. What does it mean? So usually what happens in fault zone, that is whenever the fault occurs, what happens? It triggers more circuit breakers. Actually, say if the required circuit breaker to trigger in number is 1, so what happens there? More than 1 in number circuit breakers get trigger. So what happens there? We can't avoid that. So we can make less. We can make less. How that can be made less? That can be made less by what? Overlapping of the protective zones. Overlapping of the protective zones. See, your transformer is one protective zone and generator is another protective zone, means both protective zones should overlap each other. Thus, by doing so, we can reduce the too many circuit breakers tripping. Let us understand by this diagram here. Okay. I will reduce size. Wait a second. Yeah. Now you can see here, these are the two generators of a so and so substation. You can see both are parallel in nature, and again see the dotted line which is shown here, that is here what? That is a generator protective zone. Okay, is one of the protection zones. Okay, this is one and this is another, and here both collectively called as generator protective zone. Okay, and you can see the second thing which after generator is connected is circuit breaker. Okay, circuit breaker, and after circuit breaker you can see there is a one more circuit breaker here. Okay, second circuit breaker is connected, and again you can see this is the dotted line. which I'm calling it as what? High voltage switchgear protection. Anyhow, we know that generator generates voltage at 11 kV and all. So what happens there? This circuit breaker as well as this circuit breaker, what come under what? High voltage circuit gear, high voltage switchgear protection. Okay. See, overlapping I was telling, right? See, the generator protection zone as well as the high voltage switchgear protection zone are overlapping each other. Yes or not? See, this dotted line and this dotted line are overlapping each other. The reason why we need to overlap is none of the so that no any equipment or element is left out of any of the protective zones. And again, by doing so, what happens? By doing so, we can reduce the too many trippings. Means the overlapping should be less. Okay, overlapping should be less so that we can reduce the number of trippings, unnecessary trippings of the circuit breaker. Got it? So this is the one, and this is the second one, that is high voltage circuit gear protection. And you can see that the third zone is transformer protection zone. Okay, the first one was generator protection zone, second was the high voltage generator protection zone, and third is transformer protection zone. You can see this is a transformer. It steps up the voltage from 11 kV to so and so voltage depending upon the system, power system design and all. Okay, what noticeable thing you can see here is your high voltage switchgear protection zone as well as transformer protection zone are again overlapping each other. Yes or not? See, they are overlapping each other. Okay, and again the overlapping should be less so as to reduce the circuit breaker, unnecessary circuit breaker tripping. Next, you can see extra high voltage switchgear protection as well as transformer line protection zone are again overlapped each other. You can see this is your transformer line protection zone as well as this is your extra high voltage switchgear protection zone. Both are again overlapped each other. Okay. Then coming to again one more extra high voltage switchgear protection is there at the end of the transformer line protection. Again you can see this zone and this zone again are what? Overlap each other. Thus by doing so, one thing will be very much clear that no element is left out of the protective zone. So each element falls on one or the other protective zone. Okay, one or more protective zones. So one thing you need to what? Make sure that the overlapping should be what? Less as possible. Overlapping should be made, but it should be less as possible so as to what? Reduce the unnecessary tripping of circuit breakers. Okay. So let us move to the next topic, that is primary and backup protection. Okay, so let us understand what exactly primary and backup protection mean. As the name itself indicates, so we are contrasting the topic with respect to relays. Okay, so primary relay is what? Forefront, or else you can call as first line of defense in the power protection. If primary fails, then only what happens? Your backup protective scheme will come into action so as to clear the fault as a second line of defense. So primary line of defense is nothing but your primary relay, whereas second line of defense is called as is with respect to backup relay. Okay, and again power system engineers should design power system such a way that the reliability of protection scheme should be at least 95%. Okay, so means there should be uninterrupted service, at least a very less what interruption should occur in the power system. So consumers as well as industrial loads are what? Intact with the generating system or generation plant. So we know that backup relay works only when primary relay fails. Okay, so it is not like even after primary relay works, backup relay will come into action. No, it's not like that. Only when primary relay fails, then only your backup relay will come into force or come into action so as to isolate the faulty part. And again one more requirement of backup relay is it should be independent of the factors used by primary relay. So whatever our primary relay depends on, whatever factors our primary relay depends on, those factors should be independent, or backup relay should be independent of those factors, so that those factors will not affect the operation of the backup relay. Okay, and also make sure that your backup relay is placed at different station so far as possible. Okay, so this is one of the requirements of the backup relay. It should be far as possible, and again it should be placed